Good morning to all of you. My name is Mark Lacoste. I'm a senior research scientist at Orange Labs, and I'm a technical leader of the H2020 SUPERCLOUD European project. And today I'm going to talk about this project that has been going on for the past 3 years, about this user-centric view of clouds security. So what is the project about? So the project is trying to overcome a number of hurdles of cloud computing. Mainly, you know that cloud computing has a lot of problems, mainly about interoperability, about security, and about lack of control over users, mainly because the infrastructures are very monolithic, a lot of attacks, and the problem of vendor lock-in. And so for this, when we started about the project, we felt there was a need to change the vision from a provider-centric vision of cloud security to a user-centric vision of cloud security. And this is what the SUPERCLOUD project is about giving the user back control over security independently from the cloud providers, thanks to a mediation layer, which is called the SUPERCLOUD, based on original ideas by IBM, decoupling production of cloud resources by the different providers to their consumptions by users, in order to be enabled to fully customized cloud security and building what we call user-centric clouds. So there are 4 main challenges and principles behind this. Of course, security has to be self-service to be fully customizable. It has to be also self-managed, the key problem of automation, in order to overcome sheer complexity in all layers, from compute, data, and network. It has to be end-to-end. Think about encryption algorithms. There are wide ways to protect data, user-centric with proxy re-encryption or storing data in the cloud. How do you give a homogeneous experience to protect data? And also the problem of resilience based on the data availability in a multi-cloud context, or in order to be able to protect network virtualization, virtual networks in a multi-cloud context. So this is what SUPERCLOUD computing is about, and it gives increased customizability to users independently from the cloud providers, and it also opens new business opportunities. So the project is a consortium across a number of countries. It was led by Technikon, which is an Austrian SMEs. Technical lead was by Orange. And the architecture work package was led by University of Darmstadt. And then there were 3 core work packages from virtualization by Orange, data protection by IBM, networking by University of Lisbon, very cutting-edge work by Institut Mines Telecom, and also in order to validate the framework by healthcare partners, Philips and Max Data, which is a leading actor of healthcare in Portugal. So the project has been going on in 3 years, and if you're interested, please do not hesitate to check the project website. So SUPERCLOUD is a vision. It's also a framework, end-to-end security framework to manage these resources really in a transverse way from computing, data, and network, in order to build the abstraction that we call these user-centric clouds, these U-clouds. And thanks to the SUPERCLOUD mediation layer, we are going to be able to build this and to deploy and build and run these U-clouds for a number of verticals and for a number of customers. For instance, the healthcare, the blockchain, financial market, telecom industry, and this opens in turn multiple exploitation paths. And in the project, we focus mainly to validate the framework on the healthcare market, but there are also many others. So a bit of word about the vision. SUPERCLOUD is a security management plane, and it's also a modular plane with frame. So basically, the framework is a set of components, and we try to decouple in order to be able to be as modular as possible the compute plane, the data plane, the network plane, and in a cross-cutting manner, the self-management, in order to build this UCloud abstraction. And basically, we try to reconcile two opposites, the self-management of security for automation and the self-service of security to give back user control of security independently from the providers. And also, the two opposites, the control over security in the private cloud and the lesser control but the greater scalability that is enabled in public clouds. So this is an overview of the SuperCloud framework. So there are a number of components that have been developed by the different partners. So the framework is open, and the idea is to be able to build your secure UClouds. You assemble them according to your security requirements. So on the computing plane, you will find a number of components to achieve a distributed virtualization across providers. So to run UClouds, virtual machines, or containers independently from the providers. You will find components also to isolate, to provide them strong isolation based, for instance, on hardware technologies such as Intel SGX, and also to manage virtual machines or containers for self-management of security for computation. For data protection, you will find components for replicating data in a multi-cloud context to guarantee resilience. You will find resilience, distributed storage, and also security and privacy enablers, for instance, attribute-based encryption libraries, but we also have libraries for secure deduplication of data. And finally, for network management, one big challenge was how do you manage, can you define, based on security, user-defined requirements, virtual networks across clouds, and then you deploy them. So there is a network hypervisor and orchestrator, which allows you to do this, which is called Sirius. And then on top of this, there are a number of resilient services based on software-defined networking to provide resilient networks, and also security services for secure network monitoring in a multi-cloud context, and also for security service chaining. And cross-cutting all of this, you have a number of security self-management service across compute, data, and network. So some of the major results on the core technology are the release of the SuperCloud framework and some integrated demonstrator on some products of the partners, basically around two main use cases. One was healthcare laboratory information system produced by Max Data, in which we integrated a number of components. And the other was a cloud-based medical imaging platform by Philips. And then we unified them into a single demonstrator over, I think it was 5 cloud providers running in about the same number of countries. So really a multi-cloud platforms running on many countries in order to be able to identify and integrate those different components. We have high international visibility also, with over 40 high-quality publications in major security conferences. And also we organized, in order to test our vision, a workshop at the Eurosys Major Systems Conference, also organization of a summer school on security and trusted computing. Some integrated demos also to the project advisory board, in which, for instance, there is Intel. Some contributions to open source, of course, OW2, but IBM is also in the project, and with the Hyperledger Fabric, in which a number of components from the project have been contributed, such as an ordering service. And so there is this ecosystem which has been a vector of transfer of the technology and which is very active. And so exploitation plans on cloud brokerage, healthcare, and blockchain market, and also startup on Janus technology, which is let's say user-centric storage for multi-cloud technology, which is issued from the project. So now I'm going to quickly focus on the computing plane over the multiple clouds. So it's just one part of the framework. And so without going into too much detail, basically we have three main challenges. The first is virtualization, virtualizing and running virtual machines and containers seamlessly across multiple clouds and be able to manage them. Isolation and trust. For instance, secure multi-provider enclaves, and how do you manage integrity and trust? And so self-management with all those services, and how do you orchestrate them, and with a balance between the provider and the user control over security. And so for this, our response was a two-layer infrastructure. At the bottom, a distributed virtualization infrastructure, and at the top, an autonomic security management infrastructure. So just to focus, so you will find all the details on the project website. I'll just give a quick focus on, here you have an overview of the framework. So you will find again at the bottom the virtualization infrastructure. So with on the right, how do you run the uClouds? So two main challenges are how do you orchestrate the uClouds seamlessly across the multiple clouds, and in order to be able to run security services co-located with your VMs or with your containers, but also deep into the layers of your the infrastructure. And for this, we enhanced the micro hypervisor, Gnode and Nova, in order to have control over security deep within the layers, and also components in order to have high security with benefits of Intel SGX technologies and cloud FPGAs. And on the top, a number of components for self-management, for instance, for security monitoring your infrastructure, managing SLAs, authorization, software trust management, or replicating data based on geolocation, which is particularly important to have guarantees based on location of data in a multiple cloud context. So I will just give, this is, I know that time is constrained, but this is a component we have been developing, which is Orbits, which is the virtualization components. And basically, it allows you to run uCloud as a code. And the idea here is, in two lines, is you specify on one side the elements of your infrastructure to build a multi-cloud in Tosca. And on the other side, you specify the security services, also in Tosca, both in the computing plane, in the data plane, and in the cloud and in the network. And then you blend it using aspect-oriented programming in order to be able to enrich the templates. So we build an aspect weaver for this. And this allows you to deploy in turn these templates on the multiple cloud. So we started using a hot deployment engine, also with Google Cloud. And so in order to be able to really have a portability and interoperability. And also we extended this to vertical orchestration. For monitoring, and this is really the link with one of the OW2 project, which is VESPA. For monitoring, we have two challenges. The virtualization infrastructure of SuperCloud is a nested virtualization. And basically that means that you have three levels. You have the provider infrastructure, you have the user control virtualization infrastructure, which may be Docker containers, for instance. And then finally, you have virtual machines or containers. And here the challenge is, how are you going to monitor all those layers across the layers, also based on what the provider can offer you? And horizontally, how are you going to reconcile the monitoring information across the different providers? So cross-layer monitoring and cross-provider monitoring. In OW2, we developed a few years ago a framework, a self-protection framework, which is called VESPA, that has an architecture that allows you to do this. And so we enhanced it to take into account those requirements, also integrating provider-level monitoring information, also defining a REST API, and so this allows us to provide this enhanced monitoring component. There is also some ongoing work to extend VESPA to mitigate side channels, and this is really ongoing work in the past few months. And so here the idea is in two lines, is to mitigate threats. In this complex infrastructure, you will have containers, and you will have also malicious containers that can collocate with target containers and try to extract sensitive information. And this, due to vulnerabilities, either in the virtualization infrastructure or in the hardware, in the core. And this is a side channel, indirect flow of information extraction. And for this, you have attack vectors, either in the core, in the processor cache, or in across core in the L3 cache. And so without going into too much detail, we can use VESPA to mitigate this in the cross-layer fashion, either with changing the mapping of the containers between cores, or in a distributed manner, moving containers perhaps from one machine to another. And in order to, we have developed some detection method and a reaction method to do this. So to conclude, some key takeaways. SuperCloud is really a vision and framework to enable user-centric self-management of security across multiple clouds for compute, for data protection, and also for network management. In turn, it creates new business opportunities for several verticals of the ecosystem, for healthcare, for cloud brokerage, and also for blockchain. And more verticals may be supported because SuperCloud is an open framework. And so we're investigating also further verticals, actually. So thank you very much. And if you want more information, please do not hesitate to contact the SuperCloud team. And also, you will find more information in a vision paper that has been published at the IEEE, and which is available on the SuperCloud website. Thank you very much.